Just saying, if they're doing true throwback for me. You'd be down the hardback books, you didn't write in your book, paper and pencil only, chalkboard and chalk. Yeah. All right, here we go. Number 1. How many inches are in a foot? 12. So 12 minus 10 inches leaves us with? 2 inches. Good. Number 2, what's the answer to a subtraction problem called? The difference. And what was your difference? 442. And number 3, oh my. How many cups are in a quart? How many cups are in a quart? There are not 8 cups in a quart. There are 4 cups in a quart. How would we know that? How would we know that? Well, 4 times is 16. Are we just supposed to know that off the top of our heads? Not necessarily. What would you do then? If you don't know it, what do we do? All right, use your resources. Clearly, very few of you used your resources. Look it up. You've got resources either in virtual classroom, you've got it in your binder. Look it up. Now, see what you can find. We're trying to figure out how many cups are in a quart. What do you find in your resources? Does it tell you how many cups are in a quart? In your resources in your binder, does it tell you how many cups are in a quart? In your resources in your binder, does it tell you how many cups are in a quart? Or in virtual classroom, does it tell you cups to quarts? Yes or no? I think it's on the white sheet. Does it tell you cups to quarts? It tells you cups to fluid ounces, doesn't it? And then it tells you cups to pints and pints to quarts. It doesn't give you direct correlation. You have to do some work for it, don't you? Okay? That'll be the same information you get in virtual classroom because it's the same sheet. So if you know you have how many cups in a pint? How many cups are in a pint? What's it tell you? How many cups are in a pint? Here's a pint. You have 2 cups, right? How many pints are in a quart? How many pints are in a quart? 2, and there's 2 cups in there. So how many cups are in that quart? 4. So there's 4 cups in a quart. A quart equals 4 cups. And on this particular problem, we had 8 cups, and we want to know how many quarts there are. Well, there's 4 cups. There's 4 more cups. Every 4 cups, we have a quart. So how many quarts do we have? 2 quarts. Number 4, 84 divided by 7. What'd you end up with? What'd you end up with, Piper?
12.
12. Number 5. Ooh, what did you have for your picture next? Next in your picture. A rectangle that is horizontal and then a rectangle that is vertical. Okay? And number 6, what was your value for n? Are you grading? What are you doing? What was your value for n?
8.
8. How did you figure that out?
Because I multiplied 7. And I was counting on my fingers how much I got until I got to 56.
Okay, so you look for 7 times what gave you 56, all right? What's another way we could have figured it out? Lane?
You could have divided 56 by 7.
Okay. Number 7, what is our product? What is our product? Tyler?
4,200.
Okay. Number 8, we have 3/4. What's 3/4 worth? What's 3/4 worth? 3/4. Adam? We have 2 dimes. What's 2 dimes worth? 2 dimes. Jonathan? 20 cents. When we add those together, how much money do we have? 95 cents. Number 9. When we add those two values together, what do we have? What do we have?
13 and 2600.
Perfect. 13 and 2600. Number 10. When we take a look at number 10, we're trying to figure out where on that number line that value should fall. So if this is our number line, and we have 0, 1/2, and 1, we want to know where 1/7 falls. 1/7. Peyton, tell me when to stop. All right, you ready? Here's the pen. Ready? Tell me when to stop.
Stop.
He says 1/7 is about in there. Any questions on that? Anybody? All right, go ahead and get that recorded, please. And as we take a look at our assignment next, you were to have lined up your numbers, lining up place value with place value. And as we compare number 2, our ones place are the same, our tenths are the same, our hundredths are the same, our thousandths are the same. Therefore, these are equal. Number 4. Our ones are the same, our tenths are the same, our hundredths are the same. We have nothing compared to 0, therefore they are equal. Number 6. Our ones are the same, our tenths are the same, our hundredths though, 6 is greater than 5, therefore we would have a greater than symbol in here. Questions on that? Anybody? Number 8, we have 386 thousandths, 3/10, 683 thousandths, and 836 thousandths. When we look at our 10th place, we're trying to get these greatest to least. When we look at our 10th place, our 8 is already the largest. So we can put that in the first spot. So we're done with that. Our 6 now is the largest with what we have left. So we're done with that one. We now have these 2 left. Our 3s are the same. 8 is greater than nothing. So it would be third in line. Leaving us with 3/10 as our last one, our smallest. Questions on that? Number 10. This is supposed to be larger than that. And this is supposed to be smaller than that. Our 1s are the same, our 10ths are the same, our 100ths are the same, so we're just looking at our thousandths. What digit would have to go in there to make that true? Lane? 4. A 4. Could anything else work?
No.
No. All right. And number 12, the 3 runners in the 100-yard dash are, oh, talk about throwback. Ooh, 100-yard dash. That's a throwback. Anybody know why that's a throwback? Who can tell me why that's a throwback? How many of you know why that's a throwback? Hands up if you know why that's a throwback. Come on, hands up if you know why that's a throwback. Why is that a throwback? Zachary, why do you think that's a throwback?
It happened a very long time ago.
Yeah, what makes it a throwback is the question. What makes it a throwback? What makes it a throwback? Lane, why do you think, huh?
You ran.
Well, I did run it, but what makes it a throwback?
Did you win?
Yes. What? What makes you think I won it? Come on, what makes it a throwback though? What specifically makes that a throwback?
Not a lot of people do it anymore?
Nope, that is not what makes it a throwback. That is not what makes it a throwback. Because I wasn't in the Olympics, folks. Oh, there's something there that makes it a throwback. Come on, come on.
Wait, no. The dash?
Nope, nope. A dash just means that it's a quick run. Oh, yeah. Okay?
The completion.
Nope. Not the times. Not the times.
Completion? Because it's like,
There's something very specific there that makes it a throwback. Something very specific that makes it a throwback. Nope. There are still competitions today, folks. Come on. But what about it? What about it? What about it? Nope, nope, nope. Anybody know? Anybody know? Huh? But you haven't really told me anything. Because I already circled it.
Oh,
Wait.
Time.
I know I'm not that old.
Oh,
Somewhere on here would tell you that I'm not that old.
And?
And then-
the completion time?
Nope, nope.
Your dash in the 80s, sorry.
Yeah, but more than that. More than that. What's wrong? What's changed? Oh, yes, but what about it? Yeah, was a television back then too. Come on. Come on now. Nope, nope, nope.
Did they run it in not yards and in like feet or something now?
Oh, you're getting closer. Nope. What is it running now, folks?
Miles.
No. Who said it? Who said it?
100 meters.
Meters now.
Yeah, they do meter dash.
Oh. 100 meters now.
Oh, Lord.
Which is slightly longer. So literally, the year I graduated, things switched over to meters. So like my junior year, my year before I graduated, was the last that they were running the 100-yard dash. And my senior year, they started running everything in meters in the county. People were running meters before that, but around the county, they switched over. Huh? Yeah. Yeah. And they're like, okay, and I'm not bragging, I had a gift for running fast, okay? It was a gift. Okay? It was a gift. My body could run fast, okay? It was a gift. All right? My record was not broken until 2 years ago.
2 years ago?
2 years ago.
What?
In the 400, that's one time around the track, it's 100 meters.
How fast?
What was your time? So, and I used to have a record in the 100-meter dash. Gosh, I can't remember what my record was in the 100-meter, but it got broken before my 400. But yeah, that's why I have the medals, because I was a fast runner. Okay. Yes, two years ago. 2 years ago. I knew the girl, and I wish I'd been at the meet, because I knew she would probably break it. Because I watched her in basketball, and I went, ooh, she's quick. And sure enough. That what? That's a curse. That would not be a gift. All right, here we go. We need to put these in order from least to greatest. So we started with, where is it? There it is. All right. 9 and 7/500, 9 and 7/10, 9 and 675,000. Whoops, we need to keep them like that. There we go. All right. So when we take a look at these, we want the least. So when we look at the tenth, here's the smallest number, right? So that's going to be our first. So we're done with that. These two are the same. There is nothing here, right? So it's going to be next, right? With this one then being last. Now, who won the race?
9.675.
Yeah, because it was the lowest time. Okay. All right. Now, because the 100-meter dash is a little bit longer, the times were slower. Does that make sense? Okay. Yes.
Wow.
Yeah. Yeah. I ran the 100-yard dash, and usually, I say usually, and I am not bragging, folks. I hope you know I'm not bragging. I had a gift to be able to run fast. I worked hard at it, but it was a gift, okay? I just could do it, all right? But I did work hard at it, because once I knew I had that gift, I worked hard at it to be able to do it, all right? So, yes, I ran the 100-yard dash. But then when it switched over to meters, I ran the 100-meter dash, but I also ran the 400, which was one time around the track. Okay, yes. Now, what high school did I go to? Let's look.
Oh my God. The Tiger. Oh my God.
Yes. Okay.
What was your time?
In the 100 meters, it was the low 10s. Like I can't remember exactly. And I'm going to say in the 100-yard dash, I'm pretty sure I was down in here, but I can't remember exactly. In the 400, I was right over 60 seconds. Right over 60 seconds. Right over a minute. One time around the track. Needless to say, I cannot do that anywhere close to that today.
What was the girl's record when she broke it?
She got right under 60 seconds.
So there's mine.
Yes. Well, yeah. I mean, that would be fun. But. All right, so here we go. Questions? Anybody? Yeah, we are. Yeah. Any questions on this? All right. Now, for number 14, you were write a word problem that can be solved by ordering 3 decimals to thousands. What I saw several of you doing was not what was intended for. You just said put these in order. Yeah, that wasn't what that was intended for. You were to come up with somewhere in the real world where decimals were used. Okay, and why would we need to know their order? You know? So questions, you know, like this, where they included a competition for times. All right, so would somebody like to share one they think would be a real life that would do it? Lane. And Lane, would you do math so we can hear you, please? Thank you.
4.729 and 4.819 and 4.670 are times per array. What is the least amount of time?
Okay, and here's what I'm going to say. I'll let you go ahead and read it like that. In the future, we are not going to be allowed to say in here, point. I'm not going to let you say it anymore. Anybody, for any reason, okay? All right? Yes, you have one you want to share?
Yeah.
Okay, go ahead.
Because of the E-class all-ran, and Tom's ran 1 and 726,000. The second one ran 1 and 827,000. And the last one ran 100 1 and 624,000. 3 ran less.
Okay. And the thing, I think neither of you put on yours was it seconds, hours, whatever. You know what I'm saying? So you want to be sure to include a label on that as well. Okay? Yes, one more. That's right.
3 fighters race on a track. Their times were 41 and 65,000.
Okay.
Second, 41 and 999,000. Second, and 41 and 99. Order,
99,000 seconds?
yeah.
Okay.
Order from fastest to slowest.
Okay, good. All right. Okay. Any questions on how to put things in order or how to compare them? Anybody? You have a question on how to do it? Okay. We ended our examples, but thank you. Okay. Any questions on how to do that? Okay. Today we're going to work on rounding. I want you to have your paper out that looks like this. And I want you to have your number tiles out. Is there anybody that's missing this paper that needs to come get a new one? What? Yeah. And like, All right, here we go. Rounding, 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 rounding. If we round with a whole number, we know to look to the right, we know if it's a 5 or above, and we round up. We've talked about that already this year using our math minutes, and you seem to have the hang of that. So today we're going to work with rounding with decimals. I'm going to read the number to you. You're going to put that number on your table, and then we're going to work from there, all right? Does that make sense? So put it on your chart as I read it, all right? 2 and 3,400. 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 300. Go get one up there. 2 and 3,400. 2 and 3,400. All right. So most of you have the 2 here, the 3 here, and the 4 there, which is correct. Okay? Now, if we're wanting to round to the nearest tenth, that means that we want, we want our final value to be in tenths place. Does that make sense? We want our final value to be in tenths place. That will tell us that we're rounding to the nearest tenth. We look to the right. It's a 4. What does the 4 tell us to do to the 3?
Keep it the same.
Keep it the same.
Equals 5.
Okay? So our 3 stays the same. We eliminate the 4. So get rid of your 4. And there it is, rounded to the nearest tenth. 2 and 3/10. Did I add any zeros?
No.
No. Does that make sense? What didn't make sense? Did the 4 tell us what to do to the 3? Did I go to the 10th place? Do I need the 4 anymore? No.
Oh, okay. I just got confused on why you got rid of it.
All right, let me ask you this. If it was 234, the 4 would tell us to keep the 3 the same. Do I keep the 4? No. I use a 0 here to keep the 3 in the tens place, right? But I don't keep the 4, do I? Okay? But did I need to put a 0 there? Keep anything there? No. Okay? Does that help you?
Yeah.
Okay? All right, let's do another one. 8 and 95 thousandths. No. 8 and 75 thousandths, sorry. 8 and 75 thousandths. 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 8 and 75,000. 8 and 75 thousandths. You should have 8 and 75 thousandths like that. Okay? Some of you had 750 thousandths. Okay? You have the 7 here, the 5 and the 0. That's 750 thousandths. This is 75 thousandths. Okay? This time I want to round to the nearest hundred. Nearest hundred. Okay? We look to the right. The 5 tells us to do what with the 7? So now we need to change that 7 over to an 8. So change your 7 to an 8. Okay? That would become an 8, right? Okay? We get rid of the 5, right? So it'd be 8 and 8 hundredths, right? Does that make sense? Okay? But we don't add any zeros, right? Okay? All right? How about 2 and 49 hundredths? 2 and 49 hundredths. 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 49. 2 and 49 hundredths. 2 and 49 hundredths. 2 and 49 hundredths. Should look like that. Okay? I want you to round it to the nearest tenth. Round it to the nearest tenth. What would it look like? What would it look like? What's the 9 tell us to do? What's the 9 tell us to do?
Round up.
That becomes a 5 and we drop the 9. All right? All right? 3 and 96 hundredths. 3 and 96 hundredths. We're going to round to the nearest tenth. What does the 6 tell us to do to the 9? Round up. If I add 1 to the 9, it becomes what? 10. I'm going to have to carry over here, so now the 3 becomes a 4, but I drop the 6. So it would be 4 and 0 tenths. The 0 has to be in the tenths place because that's what I was rounding to. Does that make sense? Okay? Does that make sense? What? I was rounding to tenths place. Yes?
Wouldn't you put down because it's smaller?
6 told us to round up.
Oh.
So when I added 1 onto 9, it became 10, but I got to carry that. I can't put a 10 in there.
Oh.
Okay? Anything else on that? Okay. Are we clear on the fact that we don't leave our digits hanging out here? Are we clear on the fact that whatever place value we're rounding to, we must have a digit there? Okay? Any questions on this? All right, put your number tiles away then. Let's turn our books to page 169, please. On 169, it shows you a couple examples there. Let's go to 170. It gives us that chart very much like what I had given you on that paper. We're putting that 11 and 815,000 in the place value chart. We're wanting to round this to the nearest inch, which means that we're going to be using the whole number. That would be the ones place. The 8 would tell us to do what with the 1?
Round up.
Round up, so the 1 becomes a 2. We drop everything to the right, so the frog is about 12 inches long.
Whoa, wow.
Okay? Questions on that? When we go down here to try this A, again we put the amounts into the table. This time we went around to the nearest hundredth, which is over here. The 3 tells us to do what?
Round up at the same.
Keep it the same. We don't change the 0, but we eliminate the 3. So our rounded amount is 14 and 60 hundredths. 14 and 60 hundredths. The 0 stays because we're rounding to the hundredth place. If we look at the 14 and 603 thousandths again, this time they want us to round to the nearest whole number, which means to the nearest ones place. Whole number would be nothing after the decimal point when we're done. The 6 tells us to do what with the 4?
Round up.
What does it tell us to do with it?
Round up.
It becomes a 5. We eliminate everything to the right because it's after the decimal point. So our rounded amount would be 15.
That's easy.
Does that make sense?
Yeah.
Okay, questions on that? Let's take a look at number 4. Number 4, they did 982,000 and they rounded it to 98,000. The directions say name the place value to which each number was rounded. What place value did we round that to? What place value? Jonathan? Stay turned around, please. Did we round it to thousandths place? We ended up at hundredths because that's 2 places to the right of the decimal point. Questions on what those directions mean? Anybody? As we take a look at number 7, write the place value of the underlying digit and then round each number to the place of the underlying digit. In number 7, what is the place value of the underlying digit? The place value of the underlying digit. That.
510.
So what is the place value?
10.
Tenths place. If that is the place value I am rounding to, what does the 9 tell me to do to the 5?
Round up.
Round up. The 5 becomes a 6, and I eliminate everything to the right. So my rounded amount would be 6/10. Does that make sense? Do we have questions on that? Okay. Take a look at number 12. What is the place value that is underlined? The place value that is underlined. Adam.
100.
Hundredths. I'm rounding to the hundredths place. The 4 is to the right. What does the 4 tell me to do with the 9? I'm eliminating everything to the right, so my rounded amount would be 4 and 49 hundredths. 4 and 49 hundredths. Questions on that? Any questions? Yes.
Do we always have to eliminate everything from the right?
The only reason we add zeros is to hold a place value. Do we need to add zeros to keep these where they belong?
No.
So we don't put zeros in. Okay? In whole numbers, we put zeros in to keep them in the right place value. Okay? Because if we want the number to be 440, I have to have a 0 here to keep it as 440. Okay? Does that make sense?
Yeah.
Okay. Anything else? Anybody? Yes. Jonathan, question? Okay. All right. From page 173 then, let's take a look at that. On 173, let's do the odds. And on page 174, you're doing all. Don't forget, this is due tomorrow. Your two-sided weekly page. I'll give you 10 more minutes to be working with your partner on that today. Okay? Your triangle partner. There are two people who are absent. So if your partner is missing, I want you to come see me. You've got 10 minutes to work with your partner on the two-sided weekly page. Two-sided weekly page. If your partner is missing, come see me. Who's your partner? Should be one more partner missing. Who's Carolyn's partner? Who's Carolyn's partner? Hey, Kaylin, who's your partner, your triangle partner?
My triangle partner was Ezra.